All right, this is my hybridization video for the acetonitrile. I'm gonna start off just drawing the Lewis structure just to get an idea what we're doing here. We have the two lone pairs there, the three hydrogens. So we have the Lewis structure. So now we can start off that we know we have linear bonds on nitrogen here. So this is a linear bond. So this carbon is linear, and this nitrogen, we know that this bond is going to be linear here. Let's start off by drawing the carbons and the nitrogen. So we start off, since this is a tetrahedral, so we can know that that's going to be sp3 hybridized. So there's going to be 4 sp3 orbitals. So we can start by drawing those. Let's see, so we got to get them lined up correctly. And we know that there's one that's poking out here to connect to the other C. Since this carbon is linear, we know that it's going to be sp hybridized. So we know that there's going to be an sp orbital that's poking out and overlapping. So this bond here is going to be sp3 to sp. So we have an sp here, sp3, 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 sp3. So we know all those are going to be sp3. And then we have the other side of this carbon, sp orbital. And then we're going to have the linear, since the linear, it's going to have two sp orbitals and two p orbitals, so that we know that those are going to overlap in this direction here. Then we have, this is the back, this is the other side there. So those are the those are the p orbitals, py. This will be pz here. We'll get the axis going here in a minute. Then we have here, we have the other sp orbital on the nitrogen. Oh. There's going to be one here as well. And we have, this is also a linear molecule, so it's also going to be sp hybrided or hybridized on the nitrogen. We have these back runs here. So these are going to also be the y and the p, z. And then we'll get the axes on here. So we have the y-axis here. We have the x-axis. Then we have the z-axis. So let's see what else. So we have to talk about the bonds. So we have the pi bonds between these orbitals here. Those are the these are the non-hybridized ones. Those are just the p orbitals, in these back ones here as well. Same thing on the front. The z connects to the z, and the y. Those are pi bonds. These are the sigma bonds here, sigma. And then, oh, we have to add the hydrogens as well. Over here, we have 3 hydrogens. Those are just S, not hybridized. Let's see, what else are we missing? Those are those, and these are also sigma bonds. And then the lone pairs live in the hybridized orbital for the N. Yeah, I think that just about explains everything.